Good afternoon. I'm a professor of mathematics. I have taught mathematics for more than 4 decades now, and I want to tell you a little bit about the first mathematics class that I ever taught. It was in the fall of 1983 at NYU. I was a second-year graduate student then, and I was given the task of teaching a calculus class. About 30 students. I was told which chapters in the book I should cover. I wasn't told much else. Perhaps I should have been told some other things. But I was well prepared for teaching the material. I understood it very well. I thought very hard about how to teach and what to teach. I prepared well. I was enthusiastic. I began to teach. After a few weeks into the semester, I noticed that the class was quieter than I wished it were. And I knew at the time already that quiet is never a good thing in teaching. But I soldiered on. After a few more weeks, the class was even quieter, and now there was distinct hostility in the room. So I realized something was going wrong, and I decided to salvage the situation by giving some extra in-class quizzes, adding homework problems to the assignments. My calculation was that people would work harder as a result, thereby learn more, and therefore enjoy the course better than they did. Well, I don't know how anyone could have thought that that would work. It didn't. And altogether, my class was an unmitigated disaster. So what I want to think about is, what went wrong? What did I do wrong? It seems that I did everything precisely as I should have done it, yet something went very badly wrong. Nowadays, I would say, here's what went wrong. I thought about how to teach and what to teach, but what I should have thought about first was why to teach in the first place. Why was I teaching math to those kids? Why do we teach math? So I would like to invite you for a few minutes to think about that question this afternoon. Why do we teach math? If I were a teacher in grades K through 8, then I would know a good answer to that question immediately. There is elementary mathematics, arithmetic, percentages, fractions, how to read a simple graph that everybody should know to follow a recipe in the kitchen or to follow the news. People should know what mean and median are, because if you don't, then you don't understand when someone tells you that the median wealth in the United States is several times lower than the mean wealth. Understanding such things is important for everybody. Moving on to the high school and college level, there is still a simple answer to the question, why do we teach math? You look around you, and everywhere you look, you see things that we take for granted that wouldn't be possible without fairly sophisticated mathematics. GPS systems are an example, medical imaging systems, efficient airline flight scheduling, the Google search engine, ChatGPT. All of physics and statistics are examples. And unfortunately, also the atom bomb would not exist without math. So for better and for worse, mathematics has affected the way we live like hardly anything else has. As a result, society has a real interest in enabling people to use mathematics creatively in the STEM fields. That's not to say that society has an interest in millions of people who have vague and perhaps somewhat painful memories of once having known how to solve a quadratic equation. That would be similar to educating millions of people in the rudiments of heart surgery, let's say. And we don't need that. We need sufficiently many excellent heart surgeons. So how does society go about achieving this goal? I think with a heavy hand. From grades K through 12, in every grade, you're required to take math courses typically. And then you arrive at Tufts University and you want to major, say, in history or in music, and you discover that you still have to take 2 more math classes. That's the math distribution requirement. But before you even got into college, you probably took an SAT or ACT test, and there were 2 subscores there. The subscores were the verbal score and the math score. There was no biology subscore and no history subscore and no music subscore, but there was a math subscore. Prestigious medical schools, until quite recently, expected that the applicants had taken 2 semesters of calculus. And this was never a requirement that was in place because practicing physicians use calculus all the time. This requirement was in place as a gatekeeping mechanism, as an intelligence test. Mathematics has become society's universal gatekeeper and intelligence tester. Now, when you use a subject that way, there are adverse consequences. I want to ask, what do you think happens when you require students to take classes that they wouldn't be taking if they weren't required to take them? The answer is very simple. Then students will take classes that they wouldn't take if they weren't required to take them. That, however, when you think about it, cannot possibly be good for those classes, because you get classes populated by students who are not motivated and who are there under duress because they have been coerced into the class, and they will ask the perennial question, when are we ever going to use this? That question has probably been asked for the last 2,000 years by mathematics students, and I'm going to say it's a very good question. It deserves a good answer. It sometimes doesn't get a good answer. But I will also say people don't ask that question halfway into a movie. Imagine The Godfather Part 2, 20 minutes in, you ask, when am I ever going to use this? In that case, the answer is, hopefully you won't ever use this. Nonetheless, people watch movies. I want to make the point that requirements and coercion affect what we teach. If you have to teach students who are there under duress because they have been coerced into the course, then you will teach what can be coerced. And what can be coerced is the performance of mechanical tricks on the final exam. Deep and rich and broad thinking about the wonders of mathematics cannot easily be coerced. But mechanical tricks can be, and that's why we see questions like these on calculus exams. Relatively meaningless calculations that a student can be coerced into performing correctly on an exam. It's quite similar to this. Coercing a tiger to jump through a burning tire. And tigers are naturally afraid of fire, so the tiger really doesn't want to do this. However, you can coerce the tiger into it. Teaching mathematics that way is not conducive to enabling people to use mathematics creatively in the STEM fields. In fact, it undermines that goal. I want to mention the second reason to teach mathematics, and it's at least as important as the first, and perhaps more important. Mathematics is good for the soul. It's good for the soul to do mathematics as it's good for the soul to play or listen to music and to paint or to see paintings, to take walks in the woods. However, if you teach people under coercion, because it's a requirement with force, then it's no longer good for the soul. This is not good for the soul for sure, and neither is this. As a result of all the gatekeeping, intelligence testing, coercion, etc., our discipline has its very own psychiatric disorder named after it. And I don't think any other discipline has this honor of having a psychiatric disorder named after it, namely the mathematics anxiety. There is a Wikipedia page on it, and there is a large body of scholarly literature on it. It's not surprising, Because if you use a subject for gatekeeping and intelligence testing and you coerce people into it, then the subject will be fear-inducing. Imagine we did this with piano playing. So everyone has to take piano lessons from grades K through 12, and then when you want to go to college, you have to submit your piano SAT score, and maybe the prestigious medical schools would really want to see 2 full-length piano recitals on the resume. Imagine we did that, then we would have this Wikipedia page, piano anxiety. I should say that's not a real Wikipedia page, that's a fake Wikipedia page, I made it up. So, coercion, I believe, is the cardinal sin in mathematics education. And there is an asterisk there. The asterisk is, if a child doesn't want to learn about percentages and fractions and how to read simple graphs, things like that, then one has to force the child to learn it. Because the disadvantage in life that comes from not understanding those things is just too great. It's like swimming lessons. We try to persuade a child to learn how to swim, and if we can't persuade the child to learn how to swim, then we force the child to learn how to swim, because life is just too dangerous for the non-swimmer. But beyond that, I believe that coercion is the cardinal sin, and it's destructive of the proper purposes of mathematics education. So here's what I would like to see happening. Reduce math requirements to an absolute minimum, only require what's really compellingly necessary. Replace coercion and requirements by persuasion and enticement. And most importantly, stop using math for any kind of gatekeeping or intelligence testing. It's really not good for the discipline, for the teaching of the discipline to do that. I believe that the level of math education will rise and a great amount of unnecessary and senseless suffering will be relieved. I'm coming to the end of my talk, and I'm actually coming to the end of my career teaching mathematics. I'm retiring this year. And I began the talk with my first mathematics class. I'm going to end the talk with my last mathematics class. I have the pleasure and the privilege to teach 52 students this semester in a class that's titled Advanced Special Topics in Undergraduate Mathematics. I select a topic for every week. It's a topic that I like to talk about, but I hope that the students will also like it. I give a lecture about that topic, and then we have a discussion session where the students work on questions and problems related to the topic. Because the class is not required for any student, and because it's not a prerequisite for any other class, I have the luxury of not having to exert a lot of coercion. I do exert a trace of coercion by requiring attendance and requiring good faith participation in the discussion sessions, but I don't give obligatory homework problems and I don't give exams. So there is only a minimum of coercion and everybody gets an A for good faith participation. I'm showing you two pictures that show scenes from one of our discussion sessions with my students' permission. The level of engagement in this class is greater than in any other class I've ever taught. And I hope that the students will walk away from the class with a sense that their ability to use mathematics creatively in the STEM fields has been improved. And most importantly, I hope that the students will walk away with a better sense for why it's good for the soul to do mathematics. Thank you very much for your attention.